Now, let's move on to the Heaviside function, also known as unit step function. We usually write it as h of t minus a or u of t minus a. They mean the same thing. The function has a simple behavior. It is 0 for values of t less than a, and it is going to be 1 for values of t greater than or equal to a. So let's take the Laplace transformation of this unit step function. Using the definition of the Laplace transformation, we will be substituting it here. Now, to make things easier, let's break the integral into two parts, from 0 to a and from a to infinity. So we are going to be rewriting it as this, 0 to infinity, sorry, 0 to a. Now, here's the key part. We know that for the value of t less than a, the unit step function becomes 0. So the integral from 0 to a entirely becomes 0. We are going to be left with this. We know for the value of t greater than or equal to a, the unit step function becomes 1. So eventually, we will just be integrating this exponent function. Let's do that. When applying the upper limit, we know that e power minus infinity becomes 0. So when we'll be applying the lower limit, that will be the final answer we'll be getting. Hence, e power minus as multiplied by s. Now, the final result is this for the Laplace transformation of the unit step function. One more thing to note is that you can see that s is in the denominator. So this value of s cannot be equal to 0. This formula is only valid when s is greater than 0. Otherwise, if it is s less than or equal to 0, the integral blows up and doesn't make sense. Now, let's take an example involving the unit step function. Imagine we are given the equation that includes the terms ut minus 2 and ut minus 3. These are both unit step functions, which means they are activate at t equals to 2 and t equals to 3 respectively. And now let's take the Laplace transformation of this expression. We can handle it easily like this. We know that the Laplace transformation of a unit step function is e power minus as divided by s. So without doing any further complications, we will directly be using this formula. We know that the Laplace transformation of a constant is going to be 1 divided by s. The Laplace transformation of this unit step function is going to be e power minus 2s divided by s. And the Laplace transformation of this unit step function is going to be e power minus 3s divided by s. Now you can notice that in all of these terms, we have s in the denominator. So we need to make sure that the value of s is always greater than 0. Otherwise, it diverges and that creates a problem. Now let's move on to the transformation of a piecewise continuous function. Before we start, it is helpful to quickly understand the difference between a unit step function and a piecewise continuous function. A unit step function is a special function that turns on at certain points. For example, its graph would look somewhat like this. It will be off from here to here, and then there will be jump when it reaches 1 at this point. And then the graph will move like this. So it is usually written as u t minus a, and it jumped from 0 to 1 at t equals to a. A piecewise continuous function, on the other hand, is any function that is defined in a separate piece over different intervals. Here, it isn't specifically 0 to 1. It can be 0 to 2 or 1 or 2. It can be anything. Let's say we want to find the Laplace transform of this piecewise function we have here. So we know that f of t equals 0 for the interval of t less than 3, and it is 2 for t greater than or equal to 3. So as you can see, the function is made up of two pieces. And that's why we will use the Laplace transform into two integrals, one for each interval. Using the definition of the Laplace transformation, we are going to be substituting f of t here like this. Now, since f of t is 0 for the value of t between 0 and 3, so this is going to become 0, meaning this entire integral becomes 0. And for the value from 3 to infinity, meaning the value of t greater than or equal to 3, the value of f of t is equal to 2. So we are going to be substituting 2 here. Now let's move on. Now let's apply the upper and the lower limits. We know that e power minus infinity becomes 0. And when we'll be applying the lower limit, it will become e power minus 3s divided by s. So writing the final answer, you will get 2 e power minus 3s divided by s.